In this lesson, we are going to consider selecting ideas to investigate. And at the end of the lesson, you should be able to know the stages in actually carrying out an investigation. We have about 5 stages. And you'll be able to tell the difference between dependent, independent, and controlled variable. And you will be able to analyze the results. Okay, collect data, analyze your data by drawing graph. Then you'll be able to make good conclusions from your graph by looking at the pattern of your graph. Now, science investigation process. Like I said earlier, science investigation involves 5 steps or 5 stages or 5 processes, as the case may be. We have the question stage, we have the prediction stage, the planning stage, the result stage, and the analysis stage. Okay, each of this stage will be dealt with in this lesson. Now, it is important to ask the right question before carrying out an investigation. A science question is a question that may lead to a hypothesis. It's like a map that will help you to figure out where you're going. Okay? It helps you to figure out the answers to some observation that you made earlier. We have 3 students here that have important science questions on certain observation they made. Chitana's question is, I wonder how the resistance of a wire depends on the thickness of the wire. Dipali's question is, I wonder how the resistance of a wire depends on the length of the wire. While Lakshima's question is, I wonder how the resistance of the wire depends on the material that the wire is made of. These 3 students asked important scientific questions on what they wanted to investigate. Remember I said that science question is the first step or is a roadmap that will help out to find or figure out a reason for any observation that you made. Now, the first student wanted to actually investigate how the resistance of wire depends on the thickness, different thickness. Wanted to find out if wires that are thicker have more resistance or less. Okay. The second student wanted to find out how the resistance of wire is affected by its length. Okay. Now the third student wanted to find out how the resistance of a wire depends on the material that the wire is made of. Will wires made from copper have more resistance than wire made from silver or from aluminium? That's a question she wanted to find out. In all this investigation, variables need to be identified and categorized, okay? In any of the investigation chosen, we need to identify the dependent, independent, controlled variable. Okay? A variable is anything that might affect what happens in an investigation. It is a quantity that we need to measure, that we need to change, or to even control. 3 types of variable can be identified in any investigation: the dependent variable, the independent, and the controlled variable. Let's take Chitana's questions, for instance. I wonder how the resistance of a wire depends on the thickness of a wire. We can identify 2 variables here: the resistance of the wire and the thickness of the wire. One of the variables is the main variable we need to observe, which we call the dependent variable. Okay? So the resistance here is the variable we need to observe or we need to measure, while the thickness of the wire here is the variable we need to change. Okay? Now there are other variables that we also need to do one thing or the other, perhaps control. We have the type of wire, voltage of the battery, and so on. Dependent variable. This is a variable that is being investigated or measured. It is a variable that is closely observed throughout the investigation. When you are choosing an idea to test, you need to make sure that they can be tested by collecting data. After collecting your data, you need to place the dependent variable on the right hand side here in your table. Write the name of the variable that you are observing here on the unit, okay, on the table. And for the other variable, you write it on this space. We're going to talk about that shortly. Okay, now leave spaces on your data table where you can write values that are measured in each of these variables. Okay, but the important thing here is that your dependent variable should be on this y side, the right hand side. Independent variable. This is a variable that is changed to get result. We keep altering the variable here to be able to get our result. In this case, we have different thickness, okay, of the same kind of wire, like what we have here, 1.0, 1.5, 2.0, 2.5. You can observe that we have to keep changing it, thickness, and from there we can collect measurements for the resistance of the wire in ohm. Okay. In Chitana's investigation, the independent variable is the thickness of the wire. Same wire of different thickness are tested to find out how the resistance will change. Independent variable should be placed on the left hand side here where we have the x. Don't forget to write the unit, okay, like what we have here on the left hand side. Controlled variable. There are variables that are controlled or kept the same or kept constant throughout the investigation. These variables need to be controlled to make the investigation a fair test. Okay? Some of the variables that are controlled in Chitana's investigation are the voltage of the battery, type of wire, the length of wire, and the test condition in the lab. Okay? These variables are kept the same so that what we're changing, the independent, and what we're measuring, the dependent, okay, are closely observed. Okay? In this way, the experiment is fair enough. Make a prediction. Prediction is the second stage in science investigation process. A prediction is using evidence from a source to see what may happen next. Okay? Chitana may predict that the resistance of a wire will increase with wire of smaller diameter or thickness. That's just a prediction. The prediction may or may not be correct. Now, it is important that we carry out an experiment and then analyze our result to be able to tell if the prediction is correct or not. Planning. This is another stage in science investigation. Planning involves 3 steps. One of it is to perform a preliminary work or experiment. Another is to select and test experimental equipment or apparatus. Next is to assess hazards and then decide how you can control the risk involved. Let's take these steps one by one. performing preliminary work. Preliminary work is a work carried out before the actual experiment. During the course of preliminary work, the student perform different things to ensure that the results are reliable. One, he decides the variable to measure, change, and control. He also decides the kind of equipment he wants to he will likely use in the actual experiment. He also decides how to work safely, how the experimental condition can be safe in the real experiment. Then he find out how to get a good range of results. Now it's like a testing process, okay, where all the do's and don'ts can be identified. Now let's start with the choosing equipment stage of the preliminary work. A student investigating a variable may decide to use a micrometer instead of a ruler, or a vernier caliper to measure the thickness of a wire. He or she may decide to use a digital voltmeter instead of an analog one to measure the voltage. The student can also decide the range of value of instrument he or she should use. Okay, in all of this, the most important is a choice of a very good instrument that will give you a precise measurement that you want and reduce systematic error. Okay, any form of system error or instrument error may affect the final result. Okay, so to avoid this kind of error involving the instrument, it's important that you select the right instrument that you want to use at the preliminary stage. Next is he decides to do the experiment safely at the preliminary stage. A student investigating how the length of a wire changes as a resistance changes the resistance in a circuit may want to use a heat-proof mat to avoid burning the laboratory bench, like what we have here. He may decide to use short wires in a circuit connection to reduce the resistance to the flow of current in the wire. Longer wires have more resistance, so the student can make that choice. He may want to use a switch or key to disconnect the batteries when the readings are not taken to avoid running down the battery. These are some of the problems he encountered and how he decides to solve some of this problem. Okay, he makes the list of all of these things at the preliminary stage. The student may also want to ensure a tight and secure connection of the circuit components, okay, to avoid fluctuative current flow in the circuit. Okay, most of these decisions are taken at the preliminary stage so that the actual experiment can go smoothly. Collecting evidence. After carrying out an experiment, it's important that evidence or data are collected in the right manner. A student can collect evidence by measuring the dependent variable, say current, as he changes the independent variable, say the length of different wires. Now, he may want to carry out several measurements, okay, or repeat the measurements. Now, one reason of repeating the measurement is to make the result more reliable and reduce a random error. Random error are errors due to that are caused by human factors. Okay, so by carrying out the experiment several times, you likely reduce this kind of error. Another reason for repeating the experiment is to identify what is known as anomalous values, and then to discard them or to retest them before finding average. Okay, so in this case we can find average by getting the sum of the measurements and then divide it by the number of measurements. So for this case here, we divide it by 3. Okay. Plot the graph to find pattern. After collecting your data, we need to plot graph or analyze the data graphically before we can make a good conclusion. But before you plot your graph, you need to understand the kind of data you're dealing with, whether it's categoric or discrete. Data can be grouped into 2, categorical or numerical, that is the qualitative or the quantitative. For the categorical, it could be nominal or ordinal. But for the numerical, it could be discrete or continuous. If the values of the variable, say x, are words, then x is a categorical variable. Okay, if I have like in the x-axis or in the independent axis, we have the independent variable or data. I have things like copper, aluminium, iron, words that are words. Then it means the kind of data I'm dealing with is categoric. But if the variables are like shoe sizes, number of people, number of paper clips, that are values, actual numbers, but have no connection with each other, then they are discrete. Okay, now for discrete data, you plot a bar chart or a bar graph or a pie chart. Okay, rather for discrete and categoric variables, we need to plot bar graphs or pie charts. Good. Now, in investigating how resistance of a wire depends on the material that the wire is made from, a bar graph is used as this kind of data is categoric, like what we have here: types of wire, copper, silver, aluminium. The independent variables here are categorical. These values will produce corresponding resistance. Okay, the resistance of copper may differ from that of silver and so on. So this type of variable or data here should be plotted like this. Okay, now I don't need to emphasize the fact that you need to label your axis, label the dependent variable on this side as the resistance of the wire. The independent variable should be on this side, the x-axis, and then the bars should be spaced, equally spaced. Okay, also the width of the bar should be the same. Good. Now we also need to write the values for the x, like copper, silver, aluminum, and then the values for the y. Good. Now plot the graph to find pattern. Continuous data. In a continuous data, there are infinite numbers between a data and the next one. A line graph is actually used to see this link. So implies that for a continuous data, we need to use a line graph. Okay. Now, if I have my value here to be 1.0 volts, then the second one to be 2.0 volts, I can have infinite number here. It means I can have 1.12, 1.13, and so on. They can also give me corresponding values of current here. Okay, after measurement. Good. Now, this kind of data that are linked together are continuous and should be plotted on a line or curve graph. Now, when plotting the graph, I don't need to emphasize the fact that the axis needs to be leveled, right? Now, the points that are plotted need to be joined with a smooth line or curve, which is called the line of best fit. We must make sure that the number of points that lie outside the line of best fit are equal on both sides, like what we have here. We have one here, we have one here. In that way, we're taking like the middle, we're taking like the average of all the plotted points. Okay. Now, sometimes some values, plotted points will be far further away from the rest. These values can be identified and retested. They are otherwise called the anomalous values. They are due to experimental errors. Okay, so we can either discard them or repeat the experiment. Okay, drawing a scatter graph. A scatter graph shows whether there is a correlation between the two continuous variables or not. If all the points lie close to the straight line, it means that there is a mutual relationship, which we call a correlation between the variables. Like here, what we have here, we have a correlation, a mutual relationship of all the data. They are closely related, or they're all falling on the same straight line, okay, or close to the line of best fit. Now, after our graph, we need to analyze the results. The pattern of the graph will help us to be able to tell the results of the investigation. If I have A and B, for instance, B being the dependent and A the independent, and I have both graphs increasing, like here, if A increases, then B increases, like any of this case, then I can say that the graph shows a positive correlation between the two variables. That's a positive correlation. But if I have one decreasing, as B is decreasing, A is increasing, and B is decreasing. For instance, I take a point here. You notice that A is bigger at this point, but B is smaller at this point. I take another point and notice that A is smaller at this point, but B is bigger at this point. Okay, it means that as A is increasing, B decreases, or vice versa. So this shows that there is a negative correlation between the two variables. Okay, now for this third stage, if A increases and B does not change, remains constant, remains the same, we can say there is no correlation between them. There's no relationship. There's no mutual relationship between the two variables. Okay. Now let's move further a little bit. This can also be an analysis of our result. As B increases, that's for the blue, A increases, but does so more quickly as A gets bigger. That is, B increases rapidly as A gets bigger. Okay? It's an analysis of this curve here. Okay? Or we can put it this way. As B increases, A also increases. At a certain point, B increases rapidly as A increases. Okay, we can see that the graph is much more steeper here. Okay, from this point it becomes very steep. The same thing applies to this one. B decreases as A increases, and does so more quickly as A becomes bigger. Okay, so at this stage you can see that it's curving up. It's curving. Okay, Now for this one here, we can see that B, for the blue one, B is increasing as A is increasing, but does so more slowly as A become bigger. Okay, from a certain point, you can see it, that the steepness keep reducing from this point here. Okay, the same thing applies to the red one. B decreases as A increases and does so more slowly as A get bigger. Okay, there are other ways we can analyze our results, especially when it's a line graph like this. In graph 1, the blue line shows that B increases by the same amount for each change in A. Okay, the red line shows that B decreases for the same amount by the same amount for each change in A. Right? Okay, now there's a special case here where the graph is from the origin 0 and we have a straight line. We can find out the relationship between A and B. This case is a special case. You can see that B is directly proportional to A. Okay, it means that if A is doubled, then B also will be doubled. This is a special case where the graph starts from the origin, from this point. Okay, now if the graph has this negative correlation like what we saw earlier, we can just give it a simple interpretation like this, that B is inversely proportional to A. Okay, as B increases, A decreases. Okay, that's what it means, but in a proportional manner. Good. Like when I double A, the other one will be halved, and so on. Guys, I want you to give a thumb up to this video, like the video. If you have any question, don't forget to leave at the comment section below. Okay, now if there's any adjustment, any improvement you want me to do, please feel free to communicate to me. Okay, I'll be happy to give you feedback. Okay, so have a nice day today and watch out for more videos like this. Thank you.